Hey guys, today I will explain you about friction. So welcome to today's episode. Okay, so let's get started. Okay, I'll just start with an example. Say this is a plane or surface over which there's a body, an object with mass m. Obviously its weight acts downwards, mg, and its normal force acts upwards. Let's say force F is applied over it and it moves with an acceleration A. This we take it as smooth surface. So in smooth surface, the force is acting, just moves the body, and there's actually no loss of energy. But let's say we have a situation with a rough surface. Just try it again. The plane, the object, the whole situation is same actually. Mass, weight mg acts downwards, normal force upwards, same force acts, but this time the acceleration changes. So why does it happen? See, actually, if you go into a magnification level over this part, we can have something like this. This is the box or object, and this is the surface. Okay, and remember this is at microscopic level. Okay, microscopic. It's not same as macroscopic. Microscopic is really small. So these are the irregularities we see on the surfaces. So friction is nothing but when these irregularities move upon each other, they oppose themselves or create a force which tries to stop the body. So this force is nothing but friction. And friction always acts opposite to the motion of the body. In this case, it acts in this direction, obviously on the surface here. This is denoted by F. So I guess you understood the basic principle of friction. Now I'll move on to types of friction. So friction are basically of two types. Static and kinetic. So what is static friction? The friction which is initially present in between the surface and the object is called static friction. Static friction is always greater than kinetic friction. And oh, sorry, I forgot to tell you about the coefficient of friction. So we write friction as F equals mu n, where n is normal force and mu here is called coefficient of friction. So this is coefficient of friction. Always in static and kinetic friction, coefficient of friction differs. In static friction, coefficient of friction is more. So coefficient of friction in static is greater than coefficient of friction in kinetic. Always static friction is more than kinetic friction, because at the initial state the potential energy is a lot more when compared to the kinetic energy. So potential energy is very high when the body is stable and the friction force is at its maximum magnitude. So as you move it, it builds up some energy that is nothing but kinetic energy, and this kinetic energy continues along with the object. Therefore, less amount of friction is present in it, because at every instant the previous instant's kinetic energy still continues to act. It's a bit difficult to understand at first, but I hope you got the idea. And as I told you, there's nothing different. That's kinetic friction is nothing but the friction present in a moving body and the surface. So that's kinetic friction, and as I told you, it's denoted by Fk. The only thing different in this and Fs is, as I told you, mu s and mu k, and always mu s is greater than mu k. So that's basically about coefficient of friction and friction. So I'll just give you an example so you can drill it in your head. Let's say a body is moving with some acceleration a on applying force F with mass m. Its weight acts down, mg, n acts upwards, and coefficient of friction is mu. So we have n equals mg. These two forces balance each other, normal force and weight. So then we have F minus F K. See, I'm writing K because it's already in motion. I wrote an acceleration, right? So I have to consider kinetic friction, MA. So this is nothing but this acceleration is caused due to the unbalance in this force and friction force. Here the applied force is greater than friction force, therefore the body is moving in this direction with this acceleration. So now finally we have n equal to mg, ma equal to f minus mu k n. Therefore a equals f minus mu mg by m. This is the acceleration. So most of the questions that you get will be based on these concepts. I'll give you better examples in the next episode, and thanks for watching.